Welcome, sir.
Yes, so we are here. Hello, everyone. Hope you all are doing great and welcome back to another exciting episode of Know Mam. I'm your host Koti Vellanki, and today we have a special talk. Right, the talk is titled as "Strengthen Your DevSecOps Pipeline with Software Composition Analysis" (SCA). So the talk is titled as "Strengthen Your DevSecOps Pipeline with Software." So, we have a special guest speaker with us to walk us through this fascinating topic. But before we dive in, let me take a moment to introduce to our esteemed guest, Rachana, who is working with EY. Rachana is just not an expert in this field, but also someone I am proud to call my dear friend. So, she is here today to share her knowledge and insights with all of us. So whether you are an expert developer or a just beginner into the world of DevSecOps, you are at the right place. Throughout the session, we'll learn about importance of DevSecOps, securing the pipelines, key principles, best practices, and also the practical tips that Rashna will walk you through to make sure you ensure having a robust development process. So without any further delay, I invite you all put your virtual hands together to give a warm welcome to our speaker Rachna. Rachna, the stage is yours. Please start with
Thank you
your
very much,
introduction.
Koti, for your kind introduction. Right? Hi, everyone. Myself, Rachana. I'm currently working at EY as a DevSecOps engineer. So, like today, I just got a chance to introduce, like, share my knowledge on the domain that I'm currently working. So, thank you so much, Koti, for this opportunity. Are we good to start, Koti?
Yes, just give me a second. I'll put the
Sure.
screen.
Sure, please. Take your time.
So here we go. Yes, Rachna, slides are here.
Great. Thank you, Koti. So now, as Koti already gave an introduction of what exactly the thing that we'll be discussing here, so that we mainly concentrate on the software composition analysis, how we can implement that in your organization, and how we can integrate that in your DevSecOps pipeline, how efficiently it will be helpful in from the perspective of security, right? It's mainly concentrated on the open source software thing. Now, Koti, yeah, please click on the next slide. So, before diving into what exactly is software composition analysis, we just wanted to have a look at what exactly is DevSecOps, right? What exactly is secure SDLC? So, DevSecOps, as the name itself is suggests, right? It's integrating the security in between the DevOps process, right? So, integrating the security practices in the DevSecOps process or the SDLC, right, from the start to deliver of the secure applications efficiently. So now coming to know that what exactly is DevSecOps. Now let's try to understand what exactly are the objectives. So the main use of having the DevSecOps implemented at your org is to automate, monitor, and apply the security at all phases of SDLs, right? So in the traditional method, what exactly was happening is the teams were following the waterfall method. So waterfall method, it's a sequential process involved for the software development lifecycle where the team has to wait. Okay, now let's say the initial phase is requirement and then planning and then development and then testing and then it goes to the production, right? So each phase of group of the people whoever is working, now let's say the develop testing team has to wait for the development team to complete, then the testing is complete, then only it will go for the production. So before going into the production, before of that only security testing will be done. That too, it was very much manual, right? So security was not that much considered when it comes to the waterfall model, right? So over here the main reason why this DevSecOps came into picture is we want to implement security, we want to bake in the security in each stage of SDLC, right? So hope you are able to see the flow over here. This is the flow of secure SDLC, as the name itself suggests, is securing the software development lifecycle, right? So So here, the initial stage, it comes to the planning stage where the teams, the project teams, will define their requirements irrespective of whether security requirements or how exactly the project has to take it up from each stage, from the start of the development, right? So in that stage, there is nothing much to add over the security thing, and coming to the next stage where the code stage starts, right? So here the developer comes into picture, right? So he'll start writing the code. When he starts writing the code, at that time he'll be using some IDE integration. So it can be Visual Studio Code, or it can be Visual Studio, or it can be, if you are using a developing a Java application, it can be IntelliJ, Eclipse, and if it is a Python, then it can be a PyCharm, right? It depends on each of the tech stack. So this IDE integration, what the development team can do is, as he writes the code, when he is writing the code within the IDE, there is already a plugin available, right? The software composition analysis tools will be having a plugin available in each and every marketplace of whatever the IDE that they're supporting, right? So they can directly use this plugin. As they write the code, they can check, okay, what and all the things that I'm writing is vulnerable or not, right? The open source libraries that I'm using is vulnerable or not, right? So these integration, IDE integration, helps the development team to know before itself, right? While writing the code itself, whatever the code that I'm writing is secure or not. Should I fix if any vulnerability pops up? Should I fix it here itself, right? It's the best approach. Fixing, like, it's like failing fast and fixing faster, right? So that is the IDE integration that is available for all of almost all the common mostly used IDEs as per the tech stack and the other requirements provided by each of the tool vendors. Now the second thing is, the main important thing is static analysis and SCA. So these two are the methodologies. Static analysis is also called as SAST. So static application security testing, and SCA is the main thing that we'll be discussing is software composition analysis, right? So whenever a developer starts writing the code in the source code, right, there will be two kinds of code available. One is the proprietary code, the code written by the developer, and other is the open source libraries, or it is also called as the third party code, which the developer might be using it and fetching it from the internet, because he can reuse the code which is already being developed for some particular purpose instead of writing it again, right? So now the open source plays a major role in this particular code. So this IDE integration, it is available for both of the methodologies, SAS, that is static application security testing, and the SCA, software composition analysis. So like if you're not much familiar with software composition analysis, it's the another word, the commonly used word is open source security, right? It's also called as software composition analysis. So that comes under the code at the initial stage of development, right? Now let's say after the code has been built, the development team has pushed their code to any of the pipelines, to the build pipelines like Azure DevOps, Jenkins, right? So at that particular time, not only using this tool at the initial stage of development itself, they can use this code, use the tools that is related to SAST and SEA inside their pipelines also, right? So whenever they're building the application, they can check, okay, whatever the build that has occurred, whether my build is having any vulnerabilities or not, whatever the code that I've written is having any vulnerabilities or not, right? Or if I've used any of the open source libraries or the packages, is it secure to use it? Or if it is vulnerable, how can I go and upgrade it, right? So with the help of these two main tools, SAST and SCA, so like here, as you can see, this comes under build stage. So build stage, once it comes after the code has been built, and after that it is pushed to the build pipeline, right? So for this particular two tools, SAST and SCA, the source code is required. It can either be the raw source code. Some tools just accept the raw source code and scan accordingly and provides the results, whereas some tools can just uses the build, that is the build of the source code that you have developed, and uses that as an input and provide us the results accordingly, right? So the major difference between SAST and SCA is both of them require the source code as their input, whereas SAST is mainly used to check the vulnerabilities. If you are having any vulnerabilities in the code written by the developer, that is the proprietary code, right? Whereas SEA, it comes majorly to check if there is any vulnerabilities exist in the open source libraries that the team have used along with their proprietary code. So that's come. that's on the build stage thing, right? Now coming to the test phase. So here test phase you can see IaaS, that is interactive application security testing, and DAST is dynamic application security and container scans, right? So first dynamic application security testing, that comes like when the application is ready, like it has been deployed to some environment, it can be the UAT or QA. So this thing, that's dynamic application testing, it usually happens at the QA environment or the UAT environment just before the production. It is almost ready to the same replica of the production set, right? So what exactly this needs is, as I mentioned earlier, this will here will be providing the application URL as the input for this tool. So what it does is it scans the application as it runs and then check if there is any vulnerability exists as the application runs. So that is the one thing over here, right? And coming to the second thing, container scans. So container scans is applicable if the application is containerized. If you are building your containerized application, you will be having the images. So when you're running that images, the containers will be created. So even the images is nothing but the software, like it is a unit of software that you have packed, like in order for your application to run, including all the dependencies, libraries, and all the OS requirements, everything. It is just packaged as an image, right? So here, even that image can contain vulnerabilities or the malicious software or the sensitive data, etc. Right? So here, that check is also happening, and after that, the pre-release happens, and then it goes to the deployment, and then it goes to the operate and monitor thing. So initially, the code, we understood that the ID integration happens, and then SAST and SCA, and again at build, SAST and SCA takes place, and test either IAST or SAST and DAST and container scans. So the whatever the thing that we are referring over here, SAST, SCA, IaaS, DAST, and container scans, all these things are a part of DevSecOps process. The scans, the tools, and the process that we are implementing inside our DevSecOps pipeline. Right? So now I think we are clear with this particular concept. Now let's proceed further. Okay. So now we are aware that okay, what and all the methodologies that we can implement from the DevSecOps perspective at each stage of SDLC. Now we'll have a look at what and all the open source tools available that we can play with, right? So first is software composition analysis or the open source security. So there are several tools available: Open OAS dependency check, Sneak, and Mend, Bolt, and Valor. These are the open source tools that you can have some hands-on related to the open source security. How exactly that check happens? We do have a demo on Sneak free trial as well as of now at the end of this session. And I just wanted to list out what and all the open source tools that is available so that it will be helpful for you and you can have some hands-on and just go through it. Now coming to the SaaS, static application security testing. So in that field also we have several open source tools, but I've listed a few mostly used ones. SonarQube, Bandit is mainly for Python, then SemGrep. And for Dash, it's OS WSAP. Then coming to the container security tools, Trivi and Clade. And IAC scanning. So what exactly is IAC scanning? This one we haven't discussed in our previous thing, right? When we are talking about secure SDLC. So this IAC scanning is nothing but the infrastructure as a code. So where we are managing and provisioning the infrastructure by writing it as a code. So in order to check that code, whether it is actually vulnerable or not, whether it is having any health issues, the code quality checks and other things, we are using some other tools. The open source tools available are Trivi and Checkmarks Kicks. So this is just an overview of what and all open source tools that is available. And now let's dive into the software composition analysis. So, what exactly is software composition analysis? So, as I mentioned earlier, software composition analysis, it's also called as an open source security, what the most people are aware of. It's an application security methodology for managing the open source components, right? That's the main thing, managing the open source components. So using this tool, the development team can quickly track and analyze, okay, there what are the open source components that they're using, whether it is being deprecated or not, what are the direct dependencies and what are the indirect dependencies, whether it is having any vulnerabilities, what is the license associated with each of these open source components that I'm using in my code, and all, right? So this is just an application security methodology mainly related to the open source components, right? It can check the licenses issues, vulnerabilities, and if there is any vulnerabilities coming from direct or indirect dependencies, if there are any deprecated libraries that we are using or not. So that is an overview of what exactly software composition analysis that we'll be diving into. Now it's let's try to understand how this tool works, right? We just got to know, okay, it is just detects like what and all the open source components that we are using in our source code, and whether it is vulnerable or not, whether it is having any licenses issues or not, whether it is deprecated or not. But how exactly it actually works in the background, right? So whenever we are taking any of the tools, it can be any of the open source tools or any of the other commercial tools available. So how exactly this SCA tool works is, first I try to identify the manifest file. So when I'm referring to the manifest file over here, it is like the file where you'll store all the metadata of the open source components that you have used. So just to give an example, let's say if you are using any Node.js application, if you're developing any Node.js application, then the manifest file would be package.json file where you are listing out, I'm using this particular open source library of this particular version and all the metadata related to that, right? And if it comes to Python, there will be requirements.txt file, and if it is coming to the NuGet, it can sorry, if it is coming to the .NET, then it can be csproj files, package.config files. It depends on each of the tech stack that you are using. So but each of the projects will be having, depending on the tech stack, a manifest file where the developer will be defining, I'm using this particular open source library of this and this version, right? So what happens whenever an SCA tool scans, it goes and checks your source code, it tries to find this manifest file. It tries to find if there is any manifest file exist in your source code or not. If there is any manifest file, initially it will go and check the manifest file and then try to download what and all the things that is listed, and then matches with this database and provides us the results accordingly, right? And now there are some other tools where they are taking the input as the binary files once the code has been built. So that is the second methodology. And the third one is SCA tools. Like as I mentioned earlier, it mainly checks the open source components. So when we are containerizing the application, we are building the images. So that particular images will be having, even like we're packaging that application, like we are packaging, taking the OS libraries and what and all the dependencies is required. We're just packaging it and we are providing it as an image, so that anyone from the team, if we are able to fetch that image and if we can run this, it will automatically go and downloads all the requirements and it should be able to run in any of the environment, irrespective of whether it is like usually before what exactly was happening is before this containers came into picture. So now let's say I have developed the code in my system, right? But whenever my teammate who is working on the same project, if he is trying to run that particular application, he might be facing some issue saying the system requirements is not matching and some dependencies are missing, right? So in order to avoid that, what we did is we packaged, whenever I'm developing the code, complete code is ready of an application, I'm just packaging it as an image, including all the other dependencies, software, what and all the requirements is required for us to run that particular application, right? So this SCA tool, it also scans this container images and checks if there is any vulnerabilities exist related to the open source components that we are using, right? And coming to the SCA tool, you must have been familiar with the term called as software bill of materials. So this software bill of materials is nothing but a collection of the open source components, whatever the open source components that the tool identifies. In addition, like associated with its license, whether it's vulnerable or not, whether it's deprecated or not. So all the list of the open source component list, it will be provided by this particular tool so that you can keep a track of it. Okay, like when I scan with the SCA tool, it determined these many open source components. Sometimes the developer might have missed to declare it in the manifest file, right? So it goes and checks the entire source code and then it lists out what and all the open source components, the associated licenses and the vulnerabilities accordingly, and provides the development team, the project team, the software bill of materials. So that is related how.
One quick question, Rachana, here. So, whatever the methodologies you have mentioned, all these three different methodologies. So, for every single method, we have a different tools, right?
No, it actually depends on the tools, Koti, how exactly it works, right? So what exactly happens is initially the tool goes and check if the manifest file. That is the first, irrespective of whatever the tool that you are using. If it doesn't have any manifest file, then it goes and checks the entire source code, right? And now the second thing is some tools are defined in a way that they have been developed in a way that it needs just the binary as the input. We can't provide the raw source code,
Okay.
right? You have to provide the build, then only it will go and scan, right? And now coming to the third thing, if you are using that is also called as the binary files, you can just go and it will go and scan the entire file system. If the binary files is also not there, we are telling we can tell the tool also, it depends on each of the individual tool. I don't know what and all the open source components that I'm using. I just want the tool to go and scan each of my line of like entire source code. So tool goes and scan each of the thing, and what it does is it creates a hash value for each of the file or each of the components that it forms. So if that
Okay.
hash value is matching with its database, then it confirms, okay, this is an open source component and provides all the results according to the whatever the values that is associated, whether it's vulnerable or what is the metadata associated with that.
Okay. It also match with the vulnerabilities as well.
Exactly. So when not match with the vulnerability, so first it will calculate the hash values, right, for each of the open source components. And
Mm-hmm.
if that hash value is matching with any of the values that is present in its database. Now let's say we are taking one example of pandas. It's a Python library, right? Now tool finds out, okay, this is a pandas library and it calculates some hash value, and its
Okay.
database it already have a pandas library and some calculated hash value. With that hash value it has already stored the information, what is the vulnerability with that version, and what is the license with that version, whether it's actually secure or not, right? So since there is a match between these two hash values, it will just provide and upload that results to the portal, whatever the data that is associated with that particular library present in its database.
So the database you're talking is the tool specific database, right?
Exactly. It can be tool specific database, and these tool specific databases they are integrating with like NVD database and some other GitHub
Mhm.
repositories and all.
Got it. Got it. Yeah. Please go on.
Great.
Yeah.
Sure. So now we have understood how exactly the SCA tool works, right? Now we'll have a demo on how exactly we can scan some code, the source code that we have in handy, and how we can scan it with the SCA tool. So currently I'll be using a Sneak. It's a free trial version that is available. You guys can also go and try, and you can just give a hands-on. You get to know how exactly it works and what and all the results that it provides, right? So now, Koti, I'll just like to share my screen.
Yes. Sneak is a open source tool, right, Rachana?
It is having the open source version as well, and commercial version is also available. So as of now, I'm using the open source version, Koti.
Okay, got it, got it. Thanks.
Yeah. So now, first we'll dive into how we can scan this particular tool in our pipeline, in our DevSecOps pipeline, right? So when I'm referring to pipeline, it can be of any of the CI/CD tools that you are using. So it can be Azure DevOps or Jenkins or Circle CI, etc. As of now, I'm using Azure DevOps, like how we can integrate this sneak in our pipeline, and how we can scan and how it discovers what and all the open source vulnerabilities is present, what is the license associated with that, etc., right? So now I'm using Azure DevOps. It is also a free trial version is available. You guys just can go and sign it up. So it's absolutely free. So now I'll be using Azure DevOps for my demo purpose. And here you can see I'm just using a repository called as Node Code. So this Node Code, it is an vulnerable Node.js application from the OAuth side. I've just went to their GitHub repository and I've integrated. I'll just open their repository just in case if you guys want to replicate the same. Yeah. So this is the same repository which I've used in my demo. This is a vulnerable Node.js application developed by OWASP. So it is completely vulnerable. So we will be getting a lot of vulnerabilities. This is the one, right? Now I just go back to my Azure DevOps window. And here, as I mentioned earlier, you can see in my pipeline, I have added two tasks. One is related to the npm install. Another one is the Sneak plugin have it installed, downloaded from the marketplace of the Azure DevOps, right? So as I mentioned earlier, the repository that I'm currently using is Node code, right? This is a Node.js application. So since this is a Node.js application, I'm using npm as the package manager. So there is something called as package managers, with like package managers for each of the tech stack. Like let's say for JavaScript it is npm, or for .NET it is NuGet, or if it is Python it can be Conda or Pep, etc. Right? So in this application I'm using npm as the package manager. So what I have to do before using any of the tools, right? So it can depend on each of the tools. So some tools will be having the feature where it automatically goes and installs whatever the open source libraries that have declared, but some tools might not be having a feature, so that's why we have to install it explicitly before running any of the SCA tool. So here I'm using Sneak plugin. Before that, I'm using a task called as npm install. npm install. Npm is the package manager for the JavaScript, and I'm telling that I'm just adding this also a plugin. This is a plugin that is available in the Azure DevOps itself. I'm installing. When I'm running this particular task, it goes and checks my manifest file and it will download all the dependencies that is present in my manifest file. As I mentioned earlier, the manifest file is the place where the developer has declared what and all the open source libraries that he has used along with the version. In this case, the manifest file is the package.json file. So here you can see it is asking me like where is the package.json file it is located. For that it will to go and install that dependencies accordingly. So since I have not mentioned anything here is it is always redirecting to the root directory of this particular repository. So it is already present in my root directory. So that's why my default working directory over here is defined as root directory. I'm not adding any path over here. Now, after installing the dependencies, we are installing the Sneak task. So this is the Sneak plugin that is available, which you can utilize. Yeah, so this is the Sneak plugin that is available, which you can utilize for scanning any of the SCA or for the container images. So this plugin is available. As I mentioned earlier, I'm using this free trial version. You can just go and sign up, and once sign up is done, you can just download it from the marketplace, and then you have to add an authentication token from the dashboard of your profile from the sync dashboard. I'll show you how to get fetch this API token also later. And then I have to create a service account here, like just adding the API key for me to authenticate. Okay, this is like from my end, I'm authenticating, and all the results of the scan that I will be initiating will be published into my dashboard. So that will be having a look later. So now here I'm just giving this is the name of the plugin and this is the authentication token that I'm passing. And here it is asking me what I need to test. So two options are available. One is application, another one is container image, right? So here I'm going it with application because I'm telling like Sneak that I have the source code available and I want to check it from the open source perspective, whether what and all the open source components is there, what is the vulnerabilities, licenses, and the other things associated with that. If you are scanning an image, container image, then you can go and click on this particular option, then it scans accordingly, right? So now once this is done, you can just go directly over here. So I think I have all the other options. I have set it as however the default it was there. So the testing severity threshold. So whenever, as of now, the Sneak is using the severity testing of it is using the scoring method, vulnerability scoring method of CVSS v3. So this CVSS v3, the severity levels are critical, high, medium, and low. right? So here I can set up what is the threshold that it is required for, above what vulnerabilities like the it has to report for, to checking my database, right? So when to run Sneak Monitor. So this is a feature that is available from Sneak, like it automatically goes and check in your repository. Like now let's say I have scanned this particular repository and it is already displayed the results in my Sneak, right? So they it will be having the information, okay, this particular project has used this component of this particular version. It might not be vulnerable today when I'm scanning, but tomorrow it will go and scan again those components. If there is any zero vulnerability come up, and if there is any new vulnerability pops up associated with that particular thing, it will go and publish the results accordingly. So it will monitor all the results that is displayed in their dashboard and update it on daily basis. So that is why I've enabled this sync monitor, right? And after that, I'm just providing what is the name that it should be there in my Sneak dashboard. Once this pipeline is completed, I'm just giving the name as OS notebook hyphen ADO in the sense Azure DevOps, right? So this is how it's very easy to configure. You can just go with the default option. What you have to provide over here is the mandatory parameters over here is you have to just authenticate with the API key, and after that you have to just tell it like for what purpose you want the Sneak plugin to run, either to check for the container image or for the application thing, right? So now once this is done, this is how we can integrate Sneak, and I can just go and queue this particular thing. I'm just running the pipeline. So meanwhile this pipeline runs, so this is one of the method how we can integrate in our existing DevSecOps pipeline. Now let me show you guys how that can be scanned locally as well. So I'll just quickly reshare my screen.
Your your screen is still loading, Rachna. We can't
Uh,
able to see.
yes, okay, I'm just checking that.
Yeah, yeah, sure.
Okay, I'm just sharing the complete.
Meanwhile, audience, if you have any questions, please feel free to post in comments. We'll be happy to answer those.
All right, Koti, hope you are able to see my screen now.
Yes, Rachana. Yeah.
Yeah. So now, just few minutes back, we saw how we can run the Sneaks SCA tool scan in my pipeline. How it can be integrated. How I can run oftenly whenever there is a code change. If it is already integrated in build pipeline, it is just one click. Just go save and queue it. Right. Now let's say you want to run it locally. So there is an option to run locally on your system as well. So at that particular time, we can just directly go. I've already authenticated, and as you can see, I'm already inside the directory where my source code is located, right? I have to just use the command sneak test, and I have to just click on enter. It will take some moment to display the results accordingly. So here what is happening is it is going and checking my manifest file. And so one more thing, before initiating the sneak test, I've already ran a command npm install, that is to install my dependencies. So it will go and check directly those dependencies and give me the results accordingly, right? So now once let this, it will take a moment, let it complete. Meanwhile, once this is running, right, so let's have a look at how the results are being displayed in the sneak dashboard. So here what I've done is, this is the free trial version available from the Sneak. So what you can do, you can just sign it up, like it doesn't require for you to sign up with the credit card and all. You can just sign it up with your Google account or any however you're comfortable with. So once that is done, you'll be redirected to this particular dashboard, right? So this is the dashboard, and if you remember, whenever I was doing the scan, I was implementing the scan in the pipeline, or even when we are doing it in the local machine also, we have to authenticate. Okay, what exactly, like we have to authenticate, okay, this scan has been done by us, and the results, whatever the results that is getting displayed either on the pipeline or on the my command prompt will be displayed over here. So this is the key, like which I mentioned, the organization API key or the authentication token, which is required for you to add it whenever you're either running it in the pipeline or locally. First, we are authenticating, right? So we will be providing this particular key. Now I'll go to my dashboard. Let me see if this has been completed. I think this is taking a moment. Let it complete, and I've already done the scan. This like an hour back for this particular application. I just opened that particular results. Meanwhile, that is getting scanned. And now, when come to the SCA tool, solution analysis tool, so this is how the results will be displayed whenever it is scanned, and it will gives us the results related to the open source components. So here I'm referring to the project OS Node Code, that is a vulnerable Node.js application, right? Over here, we can see, as I mentioned earlier, it initially goes and check what is the manifest file that I'm using. So since I've installed the dependencies before itself, so first it find out, okay, it will check the manifest file that I'm using. So since I've installed the dependencies before itself, so first it find out, okay, it will check the manifest file, and here it is showing the whatever the information mentioned in the package.json file. This is the manifest file for the Node. Here that is the thing, and here we can have some filters as well. You can see package.log.json and package.json. What is the environment as per your needs, and what is the business criticality, and what is the life cycle, like whether we are using it at the build or production or the development phase, right? So you can have a look at it over here as well. Now the issues are loading.
Meanwhile, right, while it is loading, Rachna, I have a generic question. So, what is your
Yeah.
take? Whenever you got a requirement as a DevSecOps engineer, right? So, how will you start? Start
Mhm.
looking at these things. So, whenever you got the requirement, for
Okay, so
example,
first thing
very,
is,
yeah, please continue.
yeah, sure. Thank you, Koti. Yeah. So, Koti, what exactly happens over here is the first main thing. If you want to implement DevSecOps at our organizations, first we have to start educating the dev teams, right? So here, suddenly, like as of now, in the previous approach, the teams were just doing the security testing, manual testing, just before the production, just for the security purpose from the infosec purposes or however according to their organization, right? So first, we have to educate the teams. We have to tell them about the integrations that is available, how it will be beneficial for them. Now let's say, like if they start remediating this vulnerability at the initial stage of development itself, now when it goes to the production or for the manual review, there it will be very less value, right? It can be almost 80 to 90% of the vulnerabilities would have fixed at the IDE integration at the build pipeline itself, right? So first we have to start educating the teams about what and all tools available, how they can integrate in their pipeline, and it is also coordinating with the DevOps teams as well. So here, as the DevSecOps, we are just working directly with the dev teams and also the DevOps teams. So DevOps teams will be able to integrate these tools in their pipelines. And as a suggestion to use these particular tools is, first thing, like whenever we are using this tool, right? So the main objective, as I mentioned earlier, we are automating and monitoring, okay, what exactly is happening, whether the source that is still there in my repository is vulnerable or not before by getting deployed, before pushing it to the next stage, or before pushing it to the master branch, right? So it not only helps the development team, but from the business perspective also, it is like a, it follows one approach like fail faster and fix faster, right? So we are failing the build faster, saying that hey, you have the vulnerabilities at this stage itself. When you're developing the code, you have to go and fix it. So even the development team, that if we are not telling them, okay, once you have developed this particular code, go and fix this vulnerabilities, so right, so they can run these tools. However, now let's say they have developed a feature. So once the feature is developed, since they have already integrated in this pipeline, whenever you are pushing that to the pipeline, it will always go and do this automatic checks from the perspective of all the vulnerability tools that we are using, SCA, SAST, and all.
Yeah,
So if
got
you
it,
can
got it.
answer
Yes.
this.
Yeah. So which brings my second question, right? This is continuation. Like you mentioned, you will be
Hmm.
dealing with DevOps engineers and dev team, you know,
Hmm.
in order to start using these tools and make using them in the early stages to,
Hmm.
fail
Yeah.
first and, quickly and quick, fix quickly.
Hmm.
So, like, whom do you think like have the major role, to make this happen, right? So usually, like when the dev team usually say something like, I have this development work, I need to fix that, and I don't have time to, add these things and those things stuff. So they need to
Hmm.
integrate a new tool to the existing stack. Nowadays, we are seeing full stack developers means that it's not just development; they are dealing with the entire stack. Each and every person is handling multiple stacks. In that scenarios, as a DevSecOps engineer or a DevOps engineer, you are going to them and telling them to add one more tool in their bucket. So how do you deal with it? And whom do you think like have the major responsibility to make this happen?
Hmm. Got it, Koti. That's a good question. So over here, Koti, the development team plays a major role over here, right? So sometimes it depends on the each individual team, and also there is a person called as like security champion for each of the project teams, right? So he'll be like he is a security champion for this particular project. He'll be considering, okay, at each perspective of the SDLC life cycle, whether there's a vulnerability check happening or not, right? So as you mentioned, the development team, like the full stack developers, they're not only doing this development, they're doing the other works related to the other domain as well, right? So what happens is it depends on each of the individual organization's requirement, right? So like there will be a security champions who will be guiding the teams, okay, this has to be integrated in your tool. And now let's say like there will be sprints. So if the team is following sprints, the agile methodology, at that particular time they have to go moving further for the next sprint, they have to fix those vulnerabilities, right? It's up to their project requirements and also the organizational policies that they have implemented in their organization, I would say.
Basically, it varies from team to team and organization to organization, is what you mean.
Exactly right, Koti.
So one last question to go out of this context, right? So these days, like I myself as a DevOps engineer and I'm working in this domain. So when I see DevSecOps, right? It's a new fancy and new thing which is coming in. I'm hearing is a lot. So
Hmm.
what is the basic difference that you feel, to between you and me as a DevOps engineer and you as a DevSecOps engineer?
Okay, got it, Koti. That's a very, very good question. So, Koti, when it comes to the DevOps engineer, you'll be knowing only from the DevOps perspective, right? What is the operations, what is happening, like the deployment, everything from the DevOps perspective, from the ops person mind of the time you're thinking like that, right? So, when we are coming to DevSecOps, we'll be having a mentality where we are work with the development team also. We should be knowing how exactly the development is happening, what is the tech stack, like how exactly the code works. So we have to understand from the developer perspective also. I should be knowing security also, I should be knowing the ops related also. So it's a combination of development, security, and ops. So it's not something that, okay, if I know ops then I can come over here, like you can, but having from the security perspective, I need to able to understand, okay, developer, if these tools are used in your this one, and if you are fixing it on a regular basis, how it would be beneficial for you, right? And also working with the ops team, sometimes ops teams also comes up with some doubts and we have to work with them as well. And from the security perspective, we have to connect more with the developers because they are the ones who will be fixing these vulnerabilities more, right? But helping them to integrate with these tools, will be connecting more with the DevOps persons, right? So it depends. So as I mentioned earlier, like it depends on each of the organizations, and if there is a security champion for each of the project, then this work would be very much more like a more organized way, right? Because security champion is the one, he's like a guide who will be keeping track of what and all things is happening in this project, how it has to be, how like how mature it can be, how they can take it to one more stage from the maturity from the security perspective, right? How they can improve this process faster, combining all the development, security, and ops.
Okay, that's a wonderful explanation. I agree. And just to give no, get us some idea, right? How
Sure.
your day-to-day life will be in one day in DevSecOps engineer, like how your day starts with, ends with, that kind of generic view.
Right, Koti. So our day as a DevSecOps engineering, as I mentioned earlier, we have to work with both development team and DevOps team, and also like educate the teams first. That is the major thing. So when we are talking about the DevSecOps, is we have education is the main weapon over here. So as much as you educate the project teams, then they'll try to understand. So initially, what the developers were thinking, okay, that this is just showing up the vulnerabilities. I have to just go and fix it just for the organizational policy purpose, right? But when you started talking about, okay, this is also helpful for yourself as well, from the development team as well. So first we have to we are starting educating the teams, and then connecting with the dev teams and devops. That is our like day-to-day activity. We'll be always on contact with the dev teams and the ops teams, and helping them to educate, and how helping them to mitigate the vulnerabilities that they found with these particular tools. Yeah.
Basically, you keep on injecting the developers and DevOps team, like, okay, these are the tool and this is the place you need to put it in, and to mitigate and to get the solution as soon as possible in terms of security.
Exactly. Exactly, and also will be helping the development team for fixing the vulnerabilities as well, right? Because the development team, like, and also like if the DevOps team, sometimes they might be very new, and we have to help them to integrate these tools as well. And also when it comes to development team, they might not be much aware of the vulnerabilities that is popping up by these tools, right? So we have to give them an initial push how exactly these vulnerabilities can be fixed, and if it is fixing, and if it is breaking your core functionality, how it has to be taken proceed, like how it has to be proceed further. So all these things, Koti, I would say like DevSecOps, it's a package of development, security, ops. Like it's not that okay, if I know security then it's okay. No, I have to know the DevOps also. What exactly is DevOps person is doing? How I can help them with that? And development team, how exactly is writing the code? Whether the code that he has written is about to get any attack, or if it is having any vulnerable path that is defined, and how efficiently I can help him to improve his code, to make his code more secure.
Okay, that's well put. So that I have one question, one more question,
Sure.
Rachna.
Yeah,
Sorry.
please.
So one personal question I would say. So
Yeah.
as a DevOps engineer, for me to deal with dev team and QA and testing team, in terms of any development and testing related activity, I feel difficult. Handling with
Yeah.
and talking with different teams. Yeah, and the same way you are also dealing with multiple teams, right? If a DevOps
Exactly.
engineer, DevSecOps engineer started his career, what are the tips and tricks that you want to leave for them? So they need to deal with multiple teams and multiple people and multiple mindsets, right?
Right.
How do you have a conversation with them?
Sure, Koti, got it. So, Koti, as you mentioned, yeah, like dealing with the development team, because like they will think, okay, this code is perfect and all, but the tool reports sometimes like we are not sure, okay, whatever all the tool that is reporting is 100% perfect, right? So there can be false positives as well, false positives as well, and there can be different minds of perspectives. That is totally true, right? But when we are, what I've observed is whenever we are talking to any of the teams, either whether development team or DevOps team, and we're telling them, okay, this vulnerability is coming for the development team, and this is making your application secure. They're just thinking from the perspective of, okay, this has to be fixed just from the policies that have been set it up at the organization. If we start explaining them and telling them in a way that how it will be helpful for them, how it makes their life easier, right? Now let's say I'm talking to any of the development team and they say that okay, this tool is reporting a lot of vulnerabilities and I have to go to the production next week, right? So at that particular time we'll suggest, okay, see, these tools are available and these integrations are available. If you had used these tools, then you would have got to know these vulnerabilities at the initial stage itself, where you have having a lot of time to fix. By the time it reaches to the production, it will be very much minute, 5%, 2%, because you've already fixed at each stage, code stage, build stage, and now if you're pushing into the production, you're doing a manual review, very less vulnerabilities is there. So one thing what I observed is whenever you're talking with any of the development teams or any of the other teams, like having a different mindset, like help talking with them from the way how it will be helpful, make their life easier would be the plus point, Cody. I would say it would be more beneficial for them also and for us as well, right?
Okay, that's a lot of information. Yeah, I disturbed you in the ongoing flow. Please go on with the demo, and we'll continue with the Q&A at the
Sure.
last.
Thank you, Cody. Yeah. Yeah, so now we are back with the sync dashboard. As you can see, these are the vulnerabilities, all the open source components that sync has reported from the code that has scanned. That is the Node code, that is the vulnerable Node.js application, right? And here you can see the left side, the left side tab where we have placing my cursor. These are the severities. So these severities are defined with the scoring whatever the tool is using. So now let's see that as of now Sneak is using CVSS v3 scoring. That is a vulnerability scoring system that is followed. Like if any vulnerability score is between 9 to 10, then it will declare as critical severity, and if it is 7 to 8.9, then it is high, and so and so, right? So it depends on each of the organizations which one to go through that, right? Now let's say some organizations want to just go to critical or some high, or some organization want to go through all the ones. It depends on each of the organizations and their team's requirements, right? So now you can just filter out what and all the things, and here this is the priority score. So this priority score, this is something respect to the Sneak tool that they are providing, like prioritizing the vulnerabilities, right? Now let's say this particular source code that I've scanned is having hundreds of vulnerabilities. The developer, like, he doesn't want to fix hundreds of vulnerabilities, right? So at that time he has to prioritize among those hundreds of vulnerabilities which is more on high priority, which one have to fix, which one have to consider first, which one is something very critical. So this priority score is calculated on based on most of the context. One is the CVSS v3 severity, the scoring system severity, and whether the fix is available or not, and whether it is actually vulnerable or not, the reachability path, and whether it is having an exploit, whether there is an exploit available on the internet or not. So this particular thing, it is a feature that is available from the Sneak, where they have where the research team have added the priority score for each of the things. Here you can see this is the score. So why this priority score it has provided? It is having a proof of concept, that means exploit is there from their end, and fix is also available, and the score is a high severity one, 7.5. So that's why it is there, right? So this is the priority score that it is calculating, and now and this is the exploit maturity. Exploit maturity, they have divided into several categories, right? One is mature, proof of concept, no exploit available. Mature in the sense there is already an exploit available in the public, right? There is a vulnerability, this is the vulnerability having an exploit available, it is being public. And proof of concept is something from their end. So Sneak itself, they have a separate set of research teams, security research teams, where they'll be like doing the research on each of the vulnerabilities, trying to find trying to find if there is any vulnerabilities in the existing open source libraries. If it exists also, whether it's actually will be exploited or not, right? So that is a proof of concept, or if there is no exploit available or not, right? So now we can filter out based on our thing. Now let's say I want to check only the critical ones, and the priority score should be very much high, and it should be having fixed, and it should be a mature one, so that the developer can go and concentrate only on the ones which is of more risk for his particular project, right? Now here I'm just taking an example of one vulnerability. This is the package that is JavaScript library ANSI regex. This is the one that was present in my package.json file, and Sneak told it the library that I'm using, ANSI regex of whatever the version that I'm using, is vulnerable one, and it is a high severity one. And what is the vulnerability associated with that, and this is the priority score. And whether it's having a exploit maturity, yes, it is having exploit maturity, but that is has been configured, that has been associated with proof of concept category, right? This here, as I mentioned, proof of category is proof of concept is something that the security research team from sneak, they have found out, okay, exploit can be there for this particular vulnerability. And after this, you can see they have also provided the fix also, right? It's not something they're just reporting, okay, this is there or that is there. They're just providing, all the SCA tools will be provided for what version this vulnerability has been fixed. So if I'm using this particular thing of this 2.0 version, they have provided, I have to go and upgrade it to 3.0 version, right? And also there are some tools, sneak is also one of the tools, where they have provided automatic fix is also available. Just with a click, it automatically goes and upgrades the package present in my source code, right? And also you can see here they've provided whether it's actually can be fixed or not. Here they've provided it can be partially fixed with this automatic click. If I just go and click on this button, it can go and upgrade the package, but it is not sure it can be fixed completely. We have to check some other dependencies paths also, right? So this is how we can do the result analysis of any of the SCA tool, and how we can prioritize the results, and how we can work it further. Right, so this was the thing. Let's go over here. This is taking time. Let me go to the pipeline. We can see how the results are published over there. So this job has been completed, and here you can see npm install task is also completed perfect. And yeah, it has installed all the dependencies, and then the sneak scan, this plugin is also completed. Yeah, so it has given a summary of 339 dependencies for known issues, found 18 issues, and 104 vulnerable paths. Right. In order to view detailed information, we have to go back to the Sneak dashboard and do the result analysis accordingly. And also sometimes the tools, it depends on each of the individual tools, they'll be able to provide a summary report, not a detailed report, a summary report of whatever the pipeline scan has happened, if it is like what and all the vulnerabilities are there, how much critical vulnerabilities are there, what is the fix for that, an overview. Yeah, so this is over like a summary report which the development can see and at a higher level. But if they want to go and have a look in detail, then I would suggest them to go through the dashboard and view the detailed results published by the Sneak. Yeah, I hope. Yeah, I
Will
think
there
I'm
be any
good with
difference between this report and dashboard report,
this.
Rachana?
Koti, yeah. Like, do you have any other questions or anything anyone posted on the chat so that I can just take it up?
In chat, we don't have much questions. So, whatever the
Okay.
reports we got in Azure DevOps and the Sneak dashboard, both are same, is it?
Yes, yes, both are same. But in the Azure DevOps, it is just a summary report where it will give an overview. These vulnerabilities are there, and this is the count, and these are the paths. But if we have to go and view, like as I mentioned, the exploit availability, everything, filtering options, reporting options are much better in the dashboard.
Sneak will have extended
Exactly.
reports.
Exactly. That's
Okay,
right.
okay. So I'll see. Like we don't see any questions. So as of now, and last request, Rachna, like
So please
for
go
the
ahead.
folks who wanted to explore the same thing, right? So I already shared a GitHub repo, and you
Okay.
also can share the couple of resources like to get started and do the same exercise that you have done today.
Sure,
So it
sure,
will
Koti.
be
Yeah, I've in the PPT, if you are sharing the link, right? So there itself, I've added the reference links also, whatever the links that have referred, which is an important links for the beginners to get started with, right? I hope that is helpful. But I'll paste the link of the GitHub and the other resources as well.
wonderful, wonderful. It really helps. So with that,
Yeah.
I don't see any question. So thank you, Rachna. Thank you so much for sharing your valuable insights on DevSecOps on our YouTube channel, No Mam. And your talk is like truly helpful, and it's available in YouTube now. I wanted to like thank once again on behalf of Know Mam community, and I
Thank you
need to
very much, Koti.
really appreciate your time, effort, and expertise, and spending time with
Thank
us
you.
on a
Koti.
Sunday.
Thank you very much for this opportunity and providing me a platform to share my knowledge. Right. It was very great talking with you.
Pleasure is always us. Pleasure. No, ma'am, will be open for you to deliver talks on any day.
Great, great. Thank you very
Will be
much.
always open. Okay.
Sure.
Thank you so much, Rachna. We'll be in touch. Yeah. So please,
Sure.
I'll be sharing those resources here, and we'll do it. Thank you.
Sure. Thank you, Koti.
Bye
Have a
bye
nice
for
day.
yeah.
Bye.